Hi, everybody. In the present presentation, we'll be presenting a new data on the granites related to uranium, thorium, and potassium located in Hyderabad, India, the central part of India. As all of us know, that demand for electricity it never be decrease, especially in the non-Soviet OECD countries like India, where the population growth stands at 1.13%. The context in the next decade, uh, coal will continue to dominate the energy source, making a share primary energy source of 87% and will be a major contributor of CO2 to the global atmosphere. With increase in energy demand, the CO2 emissions in 2018 globally showed an increase of 1.7%, amounting to about 33 gigatons of CO2 in the atmosphere. Although renewable energy made considerable growth in India, contributing to about 9% from the previous year, this has not made any impact on the CO2 emission reductions. The main renewable energy source, though solar PV photovoltaic, but this source has several issues, especially the emissions of CO2 during the life cycle of solar CO2, which is extremely higher than any other renewable energy sources. So we don't consider solar PV as green energy. In that context, geothermal is still a viable option for all the countries to mitigate global climate change and CO2 emissions reductions. India, besides hydrothermal sources, it has large potential EGS sources locked up in granites that have extremely high concentration of uranium, thorium, and potassium. As you know, India is one of the few countries that contain the entire geological spectrum, extending from Archean to recent. The outcrop of granites in the Indian subcontinent is around 150,000 square kilometers. These granites occur as intrusives into early to late stratigraphic units. And the most interesting aspect is that these granites are covered by sedimentary sequence of various ages or by the Deccan basaltic flows. While Precambrian granites are exposed in the central and the southern part of India, the post-Cretaceous granites are widely distributed along the northern part of India, including Himalayas. So here is a table which shows the different stratigraphic units in India, right from Archean to recent formations. And on the right side, you can see some of the granite exposures, which are very important exposures. And given you the uranium thorium content as well as the heat production by this granite, which varies anywhere between 5.5 to 8.2 milliwatts per meter cube. So these granites vary in age anywhere between 1 million to greater than 2,700 million years. In the present paper, we report new data on the uranium, thorium, potassium content in granites occurring uh, in the campus of Indian Institute of Technology, Hyderabad. The location is shown there in the map in central part of India. And based on the data, we assess the heat generation capacity of these granites and estimate the heat flow values for this area. In fact, this is a part of our larger project to create a database on all the high heat generating granites of India and the stress pattern of those sites in which these granites are exposed for future EGS projects. In the background, you can see some of the granite exposures with various uh, designs and blocks in and around the study area. Here we report the new data on thorium, uranium, potassium concentrations from more than about 10 samples and the radioactive heat generation of these granites and also the heat flow values. You can see the radioactive heat generation varies from anywhere between 4 to 30.2 microwatts per meter cube. And the heat flows are extremely high, the highest being 342 milliwatts per meter square. And these values are much higher compared to other granites. Sorry for the poor quality of the slide, but you can still see the numbers on the right side column. These values are much higher compared to the heat generation of the granites, which are occurring in southern part of India, like Mysore, Hyderabad, and some of the important South Indian sites. Now, for EGS, of course, we know we have to have the knowledge on the stress field, stresses acting on the sites. And as we know that the Indian plate is under a stress regime characterized by north-northeast and east-northeast oriented stress maximum. And these stresses are induced on the granites due to the northward compression of the Indian plate together with the net resistive forces arising from the Himalayan collision zone. For the tectonic forces acting on the granites are of the order of 7 times 10 raised to 12 Newton per meter. And the S maximum in this province increases at the rate of 55 megapascals per kilometer, while the global average is about 29 megapascals per kilometer. Extremely highly stressed granites. Such horizontal stress regime on these high heating generated granites with estimated resources base discussed above qualifies these granites as an excellent site for initiating enhanced geothermal resources projects in the country. Now, we know that the mantle heat flow contribution to the crust is around 12 microwatts per meter square. Data is known, whereas the measured heat flow values at Manuguru and Aishwara Pet within the Hyderabad Godavari Valley, which is located about 300 kilometers east of the study area, is around 50 to 104 milliwatts per meter square. So the crustal contribution to the surface heat flow in and around this area, this site known as Manuguru, is about 92 milliwatts per meter square, which is extremely high. So obviously, the additional heat flow is contributed by these granites due to decay of uranium, thorium, and potassium. Hydrothermal systems along the Godavari Valley is driven by these high heat generating granites. As you can see in the lower picture, there's a hot spring flowing onto the surface from a bore well drilled up to 1 kilometer with a issuing temperature of 82 degrees Celsius. You can see the steam. And the above picture, you can see the steaming ground where another hot water springs are existing near Manuguru only, with a issuing temperature of more than 67 degrees Celsius. So this clearly shows that the waters, especially the rainwater, which is circulating within the granites, are emerging to the surface as thermal streams. And this gives further evidence that the GGS, the granites in this area are extremely useful as source for PGS. So based on our heat flow data and geothermal gradient, I have proposed a schematic model here. You can see the site IIT campus shown as a square. On the left side is the Deccan Traps, fringes of Deccan Traps, which is covering the granites. And at 2 kilometer depth, you can see the estimated temperature of these granite slabs with a seismic velocity of 6.5 kilometers per second. So we are sure that because of high concentration of uranium, thorium, and potassium, these granites must be releasing a large amount of helium into the emerging fluids. But right now we don't have the data, but we are analyzing the helium content in these thermal fluids and gases. And we are sure that the concentration of helium in these fluids will be much higher compared to the helium content in the Bakeshwar thermal springs in West Bengal, where the helium content reported is around 1% or more. So this is the new data where maybe in the course of time, by the next WGC, we should be able to cover nearly half of the country's high heat producing its database, and it will be helpful for initiating projects related to EGS and contributing to the global CO2 emission reduction in the future. Thank you very much. And if you have any questions, you can ask me through email or any other sources. Thank you and have a good day.